Today, what I'll do is that I'll speak about Azure ML, Azure Kubernetes, and model deployment. But before that, I want to share to you two stories. Okay, so let me share those two stories with you. First story, yes. So as I guess just um, said that I do participate in a lot of competitions. So that NASA Citizen Scientist thing, thanks for mentioning it was a data science competition. So I'm referring to this data science competition for that. So there I tried different algorithms. But the problem was that since we built so many models and the competition ran for around 2 months, uh, so it was difficult to maintain what models did I build, what parameters did I choose, and there is so many different models I'm doing, different hyperparameters. So it was very problematic to really keep a track of it. So there is a need of model management in these case of things where you're doing maybe maybe I do not know. I did during my night time apart from my work. So I did maybe 2 to 3 experiments per day. So that would come to around 60 to 70 experiments. So that was really cumbersome. So model management is a very important part. Okay. Similarly, while writing a research paper for breast cancer images classification, so I used 13 different models. Ultimately, I didn't finish the paper. That's bad of me. But but actually, it is very difficult to keep a track of metrics, different kinds of metrics, unbalanced data set, and model parameters. So these stories, why am I telling you, is that we need a very systematic platform to create Azure ML, to create models, and that's why you need platforms like Azure ML. Then AWS also has some platform. Google has some platform. You need these type of platforms so that it helps and gives the model management part to some other place where we can do. And obviously there is deployment. So we'll see all these things in the lecture that I'm going to say. Okay. So basically, now what we'll do is we'll go to Azure ML, we'll deploy the service in Azure Kubernetes, and then we will actually deploy the model, and then we'll call the model from a web service. Okay, so that's the thing. So what it is actually, there is a model train, there is a model inference, and then there is model deployment. So no worries. First thing is that there is a blog out there, which I'll share at the end of the session. There is also GitHub code. So if you do not follow anything, don't worry. Everything's there. Every line is explained. Why am I doing it is also explained. For this session, just listen in, enjoy, and ask me any questions if you have at the end. Okay. So first, what we'll do is that we'll build a model. So I'll move away from the slides. The good thing is that I just gave a session for Azure Greece and I prepared the slides, but I gave it through the notebook. So let's do that. It was good. So going by the notebook. So let's go to the notebook. So what I'm doing here is that I'm creating a workspace. So if the workspace requires a resource group and the location. Okay, and then there is the subscription ID and the tenant ID. Use yours. Mine is this. So, so this is what it is. So once I create the workspace, so what it means is that the workspace is something like it is a home for everything. Okay, so this is my Azure ML, and once I create the workspace, what happens? Don't look at the Kubernetes cluster. What happens is that a workspace is created, application insights is created, eVault is created, and storage account is created. So this is, so once I create the workspace, all these things Azure creates it for me. So you can see it once you execute the code, all these things are being created. Okay. Then what is to be done? So now model building requires data. Okay. Now the data has to be kept somewhere. So where is the data kept? So the workspace, consider the workspace like a house. It has got everything. Or whatever you require, it has got everything. So the workspace has a default data store. So what we do is that our intention, sorry, I didn't say that. Our intention is to predict the quality of wine given different attributes. So these are the attributes of the wine that are there. So actually, this is a very interesting problem. I don't know whether this data set reflects that or not. So wine quality prediction is a very important thing because it tells you about what the price of the wine would be. Okay, so these are, I have taken a very simple problem just for the illustration of the whole framework. You can take any model. So our problem is that we will be given these things, attributes, and then we'll assess the quality. So the quality is kind of like a number. Okay. So we are trying to build a model on it. So this is my whole data. And what we do is that we upload the data to the default data store. Okay. So once I upload the data, so what it will do is that if I go back to my screen out here, so this is a storage account which is associated, and within the storage account, there is a container. And what it does is that it has a default data store, and it will create the file over here. I've uploaded these two files. Okay. So what we have done till now, we have created the workspace. We have uploaded the data. We have not built any models. So let's go back here. So here is a fancy thing. What I do is that I create the training folder. Basically, I just create a folder, wine code. What it means is that here in my thing, I just create one folder called wine folder. Then what I do is that, no, now I create a compute cluster. What is a compute cluster? So you have data, uh, you have a workspace, but you need a machine, right? So as to run where the model will be built. So for that, Azure gives me SDKs in which I can create clusters of machines. So it's called a compute cluster, and I can, for this is for me a very simple thing. So I have just created a one node cluster here. So what it does in the workspace, if you go back here, in the compute section, so I ran it before this meeting. So the compute cluster is already created here. So this is a standard D2V2. You can increase the size of the cluster. Okay. So this is a cluster that I have built. So till this point, if you are with me, I have created the workspace. I have created the, I've uploaded the data. I've created the cluster. Okay. Now what I do is that I create the training script. So basically, this is my model. So I'm using a very simple thing, a decision tree regressor with two parameters, max depth and the data folder, and the standard decision tree, RMSE, and all these stuff. I'm not going more into the model building space because this is your area. This you can do anything. Any data scientist would do his own his or her model. So it's here I built a very simple model, a decision tree regressor. You can do anything because you are using the sklearn library. You can use an XGBoost, Light GPM, anything. So here I built one decision tree regressor. But now what happens is that you have to create an environment. Now this environment is something like you have built a model, and you have you now require an environment in which you can you guys are able to see my machine, see my screen, right? Hello, hello, you are able to see my screen, right? just take a pause. Okay, okay, okay. You are able to see my screen. Okay. I just go back to. So where was I? So we created the cluster, and now we created the environment. And now what we do is that what we will do is that we'll register the environment in the workspace. Now, what we do after once we create the register the environment in the workspace, we create the estimator. So the estimator is what it does is that it takes the training script, it takes the params, it takes the compute target and the registered environment and combines all of these together. So this is the estimator for that. So once the estimator is done, so what it will do is that then we create an experiment. So the experiment is a place where we put all these things together and we create the experiment. So here in Azure ML, you can see the experiment in the experiments tab. So this experiment that we have created. Now, once the experiment is done, so what we do is that we submit the experiment with that estimator information. What is the estimator information? It will have the model, it will have the estimator, it will have everything. So what would happen is that we will have the estimator, and in the estimator, what we will do is that we will submit the experiment. So we can see the experiment out here. Okay, so the experiment has all the runs. So we can submit the runs here. When you submit a run, what would happen is that now the model will get executed. So here, once you can see these experiments, there are different types of runs here. So I have done 3 runs. So I was saying, right, previously I was not able to keep a track of the experiments. Now I've got one experiment and I can change my parameters and I can do a number of runs. So these are the runs. So you see here, this max depth, I did it 10, 10, and then I did 8. And then I did the RMSC, which is the root mean square. All this is tracked. So these, you can submit as many runs as you can, and all this is being logged into this experiment in the workspace. One experiment, many runs. So this is where you feel that everything is in one place. So this concludes the training part of the thing. So just a recap, what we have done, we created a workspace, we uploaded the data into the data store, we created the modeling script, we created the compute cluster, you see the compute cluster here, we created the compute cluster, we created an experiment, and within the experiment we submitted runs. So I did only in the code, I have just put only one run. You can put as many. I ran it 3 times, so you can get it 3 runs, 4 runs, four. So that's how all these things are done. Now once I have the model, I can register the model in the workspace. What it means is that now my model is in a very secure place, and now I can use it in a number of times. So where is the model? The model is here. The model is associated with the run ID this, and it has got tags, it has got everything. So this is my model. So this data scientist or whoever is building the model can build this model and put it in that space. Like they can create a hub of all the models here. Now, I, as a say user of these models, I do not have to build the models. I'll have to use the model. So what I will do is that so as to use the models, I would require a web service or something of that kind. So what I will do as a data scientist, I'll do an inference cluster. Inference cluster is that the model building has been done, and now I do the model inferencing part of it. So model inferencing, what we would do is that if we go back here, is that we'll create an inference script. So the inference script is basically a place in which you take the data and you are going to predict something. So what you're going to take the data, say for example, you are giving the data as these, right? You're giving the data as these fixed acidity, volatile acidity, citric acid, and you're going to predict the quality, the wine. So for that, you write the inference script. The inference script is this. So it is, you are getting the model, the wine model, which is there in the workspace. You are loading the model. And once you load the model, you take the data which is coming in, and then you predict the model. Now this model is done. Now what you do is that you have to create the dependencies, because because a model itself is not alone. You require scikit-learn. In this case, I use scikit-learn, so I have to create a dependency for scikit-learn. Now for that, after it has been done, you create a configuration, inference config. What it means is that you have the script, you have the dependency, and you combine it together to create the inference config. Now comes the best part. Now what you do is that once you have all these things, now you need to create an inference cluster. The cluster here, because this is a very simple thing, right? So here you may not require a cluster, but if suppose they're in production, you would require many requests would come in, right? So you would require a cluster in which you can deploy your models. So for that, you have to provision a cluster, and for this we will provision an AKS cluster. So here I have chosen a very simple cluster because of my Azure membership. You can choose a very huge cluster. You can choose a GPU cluster. You can choose whatever it kind may be. So this, when I do it, when I run this code, I get a cluster which, if you go here to compute, you have the compute clusters for the model building, and then you have the inference clusters. This is the inference cluster. So this inference cluster is being created. You can go to this inference cluster and you can see of how it is done. So this is the Azure Kubernetes Service. So let it come in. But after you have done the inference cluster, you have the script, you have the inference script, and then what you do is that you deploy the wine model. Okay, you deploy the wine model. The wine model is deployed with a model here, and it is deployed into the inference cluster. It will take some time. I had done it before, so it is not a problem for me. So all this is done. So what it takes in is the inference config. It also requires a deployment config, so which we had already done here actually. Inference config is here, and we have also got the deployment config, and we have got the target, which is the production cluster, which is here. So once it is done, so what we do is that we want to get the endpoint of the inference cluster, because what we would do is we would take in the requests from different areas, right? We would take in from the Azure ML. All these requests would be coming in. So what we would do is that we create an endpoint. So this is the endpoint which is created out here from the inference cluster. This is a real-time endpoint. So if you see here, if you go to the endpoint, the endpoint state should be healthy. Otherwise, you cannot. So it is healthy here. So you can. So here you see the different types of the model which is being deployed. It is deployed in the cluster. It has also got an application insights also. Okay, so all of it is being done. Now, what is happened till now is that we have built a model. We have built a model using the compute cluster. We have used an inference cluster, which is an Azure Kubernetes service, and which we have deployed with an endpoint out here. This endpoint is actually here. Okay. Now, after this endpoint is there, we can now utilize it to call and see and predict the quality of wine. So what we'll do here is that we'll have the endpoint, we'll get the keys for it, and once you get the keys, then I'll pass in this data. So this data is this data. Okay, this the numbers may not match, but these are the arrangement, this data, and what I'm going to predict is this quality of the wine. So what I'll do is that so this is all the data that is coming in. Note here the primary key, which is a key, the service key, which is coming in, and the response. So response is 200. We have got the response, which is the quality of the wine, is 7. So what we have done till now is that we have got everything, and then since we have also enabled application insights, which you can see here, you can go to application insights from here. What you can do is that you go here, this application insights, and application insights has logs. Okay, and you can query the application insights for the predictions. So I've already done it. So you click on logs here. Get rid of this. Can type the query. So if you type, I think I've done it somewhere. Yes. So I've done it. So here I type the query, and then the wine service is a service, and then you can get the content here, and the predictions is 7. So this is what we have done. We started from scratch. We didn't have a model. We built a model. We created a workspace. We created an inference cluster. Sorry, compute cluster, and then we built the model, registered the model in the workspace, and then the modeling was complete, and then we created the inference cluster. So all this is in one place, all of it. So the data store is here, which we have used the workspace, the compute cluster. You see the compute cluster which was used for modeling, the inference cluster which was used for inferencing. You see the endpoints also which we have used, the models which we have registered here. We have not used any pipelines. We have not used any pipelines, but we've used experiments. So the experiment is a place where you can have a number of runs. For me, I tried 3 runs. You can try as many runs. And why this is good, just referring back to my use case, which I was saying, see, all these parameters are different, and I can log all these runs. So I can build different models, and everything is in one place. Maybe, I do not know, you can just download it, or you can query this space, and you can have all of it in one place. So this is a very good model management space. And moreover, production, I do not have to worry how will I deploy it in production. Everything is taken care. So this whole suite of Azure ML, so it doesn't come with Azure ML. It comes with integration with Key Vault, with uh, with Azure Insights, with Kubernetes and everything. So to be very honest, for a data scientist, this is something. So this is what I have.